All right. What's up, intermediate algebra? We're down to like about 3 videos left. We got one this week. We won't have one next week because of Thanksgiving. It's a short week, and then when we get back, we have 2 weeks. We have 3 videos left. That's kind of sad. We're talking about our last unit here before final exam review, which is on factoring. Factoring is one of the most important skills in algebra, being able to break down different polynomials so that we can simplify and solve complex equations. So we're going to work on the 4 main factoring methods in this unit, and today I'm going to show you the first 2, and we're going to practice those all day Tuesday, and then I'm going to show you the next 2 on block day, and we'll practice those all of block day and Friday, and then we'll go from there. All right. We'll have a question that I ask you midway through, or that I answer, and that's going to be, what is on my Mount Rushmore of movies, favorite movies? We did favorite albums a couple weeks ago. Let's do movies. Okay. So let me start by showing you this. In order for us to factor well, we need to also be able to multiply polynomials. So let me ask you this. If I told you to do like x times x squared plus 4x plus 6, like something like that, would you know how to multiply that? Do we know how to distribute and multiply polynomials? I know that we went over this on Monday a little bit, but I just want to refresh to say that when you multiply something that has the same base, like an x with an x squared, you actually end up adding the exponents. So x to the imaginary first power, remember there's always an imaginary first power that's there, x to the first power times an x squared would make an x to the third. And an x to the first power times a 4x to the first power would be 4, and then the x to the first would make x to the second. And then x to the first times a 6 would just be 6x to the first. So that would be what it multiplies out to. And what's crazy is factoring is just, it's almost like reverse multiplication. And instead of putting it all together, we're actually breaking it up into different factors, different parts. Like for example, in this first one that we multiplied, this is a factor and this is a factor, and it's in 2 parts, right? But then look, our final answer is just in 1 part. But what if we started with this and I said I wanted you to factor that polynomial? Well, that means we need to break it down into its different multipliable parts. And the first method that we're going to learn today with factoring is called the GCF method, the greatest common factor. It's where you look for something that every term has in common. This is a term, this is a term, and this is a term. Okay? So there are a total of 3 in this problem. And I am going to look to see what they all have in common. And I need to look in 2 spaces. I need to look at the numbers in the front and see if those have a common factor. And then I need to look at the variables and see if those have any sort of commonality as well. So to start, I see that there's a 1 in front of this. There's an imaginary 1 there. There's a 4 here and a 6 here. What number can go into all of those? 1, 4, and 6. Nothing can. Just a 1, really. And you never pull out a 1. A 1 is not enough. If they all shared a 2, then we could do it, but they don't, because this one's just the imaginary 1. So they don't really share a number. What about x's? We have an x to the third, an x to the second, and an x to the first. Well, they technically share 1x. They at least all have 1x. So our GCF for this problem is just x. So to factor using the GCF method, you take the GCF out, you pull it out, and then you leave behind whatever's left over. What do I mean by what's left over? Well, we basically just divided all three of those terms by x. We pulled the x out. So what's left in this first term is not x to the third anymore, it's x to the second, plus what's left in this second term is not 4x to the second, it's actually just 4x. And then what's left in this last term is actually not 6x, it's just a 6. So we have now, that is our answer. We factored the polynomial. Let's check and make sure we did it right. That's what's cool with these. You can always check. X times x to the second is x to the third. X times 4x is 4x squared. X times 6 is 6x. 4. Yeah, that checks out. So we officially factored that polynomial using the greatest common factor method. You always look, we're taking notes now. It's worth, jotting this down. I'm going to say this again tomorrow in class. We're learning 4 factoring methods, but you always look to take out a greatest common factor first. Because if you can do that, it makes all of your math easier, all of your numbers smaller, so on and so forth. Okay, so let's start with, let's just make up a few examples. I got 1 minute, and we'll do 3 examples in a minute. You can pause after each one, and so that it doesn't seem like it's going so fast. Okay, let's start with an easy one. Example 1. What if we had 15x minus 30? What do those share? Well, they share, this is a 15 and a 30. Can we think of a number that can go into both 15 and 30? I can think of 5. 5 goes into both, but that's not the greatest common factor. Remember, we're looking for the GCF first. The greatest number that can go into both of those is 15. And this one has an x, this one has nothing. So they don't share any x's. So I'm going to pull out a 15. And then 15, how do I get from 15 to 15x? Well, that's multiplied by an x. And how do I get from 15 to a 30? Well, that's a 2. So there's our answer. We factored the polynomial. We took it, we broke it down into 2 parts. Okay, one more, because that was not as fast as I thought. So we'll just do 2. Let's do 16x squared plus 4x plus 12. What? No, 4x to the third plus 12x. Let's do that. What do these have in common? Whoa, okay, so let's look at the numbers first. We have a 16, a 4, and a 12. What number, let's find our GCF first. What number can go into 16, 4, and 12? 2 can, but I think there's a bigger one. 4 can. So we are going to have a GCF of 4, but we might not be done. Let's look at our variables. This has an x squared, so that's 2 x's. This has 3 x's. This has 1x. So they actually all at least have 1x, right? They at least share 1. So our GCF for this problem is 4x. So we write that on the outside of the parentheses, and we put what's left over on the inside. How do we get from 4x back to 16x squared? What do we need to multiply it by? Well, to get from 4 to 16, we need to multiply it by 4. And to get from x to x squared, we need another x. How do we get from 4x to 4x to the third as our second number? Well, the 4's are the same, but we need 2 more x's. And then how do I get from a 4x to a 12x? Well, that would need to be a 3. So there's our final answer. So that is called factoring using the greatest common factor method. We'll practice that a lot to start off Tuesday. Last method. Difference of 2 squares method. This is my favorite. Okay, when you have 2 terms, has to be 2 terms that are perfect squares and are being subtracted, then you can use this method. That actually happens quite a bit when you have 2 terms that are perfect squares and are being subtracted. Okay, for example, let's do the easiest one in the books, and that would be x squared minus 4. if I told you to factor this, then what you do is you break it down into two things that are being multiplied together. And the way we show that is using parentheses. And what goes in the first parenthesis, first group, is we're gonna actually do like a quick, in our head we're gonna square root that, and that's gonna go here and here. The square root of x squared is x, so we break it down into x times x. And then in our head we square root that, and that goes in the second spot, which is 2 and 2. And then we'll have one plus sign and one minus sign. So why does that work? Check this out. I can show you by multiplying and it'll work. So we'll FOIL this back out. So x times x, and then x times -2, and then 2 times x, and 2 times -2. And watch what we get. X times x is x squared. X times -2 is -2x. 2 times x is 2x. And 2 times -2 is -4. Well, when we clean this up, this cancels. So we're just left with an x squared minus 4. So that shows that we did it correctly. So our answer here, if you see a problem like this and it says factor using difference of squares method, this would be our answer. We broke it down into two factors. It only works if there's two terms, they're perfect squares, and they're being subtracted. Okay, last example, and then I'll give you my Mount Rushmore. Let's do one that's slightly harder, but still the same idea. Let's go 9y squared minus 25. Okay, take a look at this. Is this a perfect square? Sure is. Is this a perfect square? Sure is. The 9 and the y squared both are. Are they subtracted? They sure are. So we know that we can use our method. So we use two sets of parentheses. We go square root of this. What would be the square root of 9y squared? That'd be 3y would go into both of those spots. And then what's the square root of 25? Well, that's 5 and 5. We do 1 plus, 1 minus, and that is our answer. If you don't believe me, FOIL it out, and you'll get the right thing. So that is the difference of squares method. Alright, so I'd love for you to take about 20 seconds and on-campus message me 2 things that you learned from this video and your Mount Rushmore of movies. So here's probably here's my 4 favorite movies. I first love this one. I hope you've seen this. Remember the Titans. It's incredible. Okay, you need to watch it. It's probably my most quotable movie. Second, this movie, just kind of wild with Tom Cruise, Minority Report. Super trippy sci-fi kind of crime thriller. Love it. My hidden sleeper that not many people know about is this movie called Frequency. If you like time travel and murder mysteries, this is right up your alley. I love it. And then probably my favorite movie of all time, if I had to pick one, is Good Will Hunting with Matt Damon and Robin Williams, rest in peace. This movie's incredible. It's got a lot of language in it, but wow, is it powerful. So that's my Mount Rushmore. Love to hear from you guys. See you tomorrow in class. Peace.